Today we are going to discuss how to represent real numbers on number line. Of course, we know real numbers means it is a collection of rational numbers and irrational numbers. So today's our topic is this one, how to represent these numbers on number line. So first of all, we know the fraction. So rational numbers. So let us take the example 1/3. It is a rational numbers. It is an example of rational numbers. How to represent this on number line? This we already learned in our previous classes. Anyhow, we'll see how to represent this rational number on number line. So first of all, we have to draw a number line. Well, first here it's a position mark 0. Then here it's 1. Then here is 2. Now we look at this fraction. Of course, it's a proper fraction. Its value is in between 0 and 1. So what we have to do next? So we have to mark this unit place into 3 equal parts. So 1 here and 1 here. So 1, 2, 3 equal parts are there. Now what we have to do? So here in 0, in this position we can write if this position is 0/3. Of course 0/3 is 3, 0, and next this 1/3 we can mark it as this is 2/3. Now here it's 3/3. Well, what's our question? What's our task? Is of course to represent this 1/3 on number line. Where is its position? Here we got the position 1/3 on number line. Now let us consider another example. See here the second question, represent 3/5 on number line. Well, so first we can draw a number line. Now here it's 0, 1, 2, etc. Now see here again, it is a proper fraction. Its value is definitely in between 0 and 1. So what we have to do next? So we have to divide this portion, this unit place, into 5 equal parts. So first 1, 2, 3, 4. Yes, well, now it is 5 equal parts. Now here we can mark it as 0/5. Here it's a 1/5. This point is 2/5. Now this point is 3/5. Now this point is 4/5, and the last one is 5/5. Of course, we know that the 5/5 it's 1. Now our task is to represent 3/5 on number line. Where is the position of 3/5? Well, it is here. So we can mark this. This way we can easily locate 3/5 on number line. Yes. Now we have learned how to represent irrational numbers on number line. Well, now we are moving to the another section, how to represent irrational numbers on number line. For that we have to consider an irrational numbers. Yes, well, we can consider √2. So here is a question, locate √2 on number line. Locate √2 on number line. That is our task. Well, let us see how to solve this one. For that, first we have to draw a number line. Well, now we can mark here 0 and 1, 2, 3, etc. Well, here is the number line. So first what we have to do means we have to consider a unit place. Well, and here we can give name as A, and this you can consider as O. Well, here it's a unit place, unit distance. We are considering a unit distance OA. The next step is this one. From A, we have to draw a perpendicular to this line, to this number line. So that should be in unit length. Well, so we can do that. See here, we mark it as B. So what we have done? So we just drawn a perpendicular AB to this number line. Its length is unit length, 1 unit. Well, now we know OB is a unit length and AB is a unit length. Well, and it is perpendicular. Now we have to join this OB. So what happened? Here we got a right angle triangle. So we got right angle triangle OAB. Now we are going to find the length of OB. So how to find out the length of OB here? Well, we have learned already the Pythagoras theorem. And what is Pythagoras theorem and its purpose also we know. Well, now by using the Pythagoras theorem, we can easily find the length of OB. So how we can do that? Well, so we can write OB by Pythagoras theorem. We can write OB square equal to OA square plus AB square, because OB is hypotenuse. OB square equal to OA square plus AB square by Pythagoras theorem. Well, now we can write what is the length of OA? OA 1 unit plus 1 square plus another AB 1 unit 1 square. Well, now it is 1 square is 1, 1 plus 1, we are getting 2. You see, OB square is 2. Therefore, we can say what about OB? OB equal to under root 2. Well, now we got the length of OB, that is under root 2. Now our task is what? Locate root 2 on number line. To do that, we have to take a compass and keep here as a pointer and radius as OB. Take a compass and draw an arc with the center O and radius as OB. So we can draw like this, and where it touches on this number line, this is the position of root 2. Why we are saying it is the position of root 2? Yes, of course, we know. If we are here, we are drawing an arc. Well, OB, the length of OB is root 2, and of course from here to here a length should be root 2. Why? Because these twos are the radius of the same circle. Therefore, if here it is root 2, definitely from here to here it is root 2. So when we are considering number line, well, here it's a 0, here it's a 1, 2, like that. Here this position comes the location of root 2. Yes, now we can discuss how to locate root 3 on number line. Well, for that, first we have to draw the number line. Here it is 0, here it is 1, here it is 2, here it is 3, and so on. Now what we have to do first? So of course, here this 0 we can consider as O, and here this 1 we can make it as A. Well, now this is a unit length. So here we have to draw a unit length. We can draw here a perpendicular which should be in unit length and mark here it as B. Now what you have to do? We have to join this OB. We got a right angle triangle OAB. Now next we have to draw a perpendicular to OB through B. See here what we have done now? We have drawn a perpendicular to OB through B, and here is mark it as C, and it should be a unit length. Now we can join, it's a perpendicular. Well, now we can join OA. Here you consider we got another right angle triangle. Well, that is OBC. So in OBC, in triangle OBC, well, we know it's a right angle triangle. Here we know the length of OB, of course we know it is a root 2, that we know. In the previous question we have already done that. So the length of OB is root 2 and length of BC 1, and we don't know length of OC. Well, here we can find out the length of OC by using Pythagoras theorem. So we can write OC square by Pythagoras theorem. We can write OC square equal to OB square plus BC square. Now we can give the values of this OB. OB value is, well, it's root 2 all square plus BC, one value, 1 square. Now that is equal to, we know, root 2 and square root. We can cancel this and this. We'll get 2 plus 1. So that is equal to 3. Now, well, we know OC square. The value is 3. Therefore, OC. Therefore, we can say OC equal to root 3. Well, the length of OC we got root 3. Well, it's root 3. The length of OC is root 3. Now we have to take the compass and draw an arc by pointing the compass on this O and adjust the compass as radius OC and draw an arc. So here we will get like that. Now where the arc touch this number line, that point should be root 3. Why is root 3? Because we know this OC and O we can give here as DOD are the radius of the same circle. Therefore, we know from here to here, the length of from here to here and here to here are same. Therefore, from here to here it's root 3. Of course, from here to here also root 3. When we consider this as a number line, of course we know this is 0, this is 1 and this is 2, 3, etc. So the position of root 3 on number line is here. So we mark. So our question is this one, locate root 3 on number line. Now consider here, locate root 5 on number line. Well, first we can mark a number line. Yeah, well, it's a number line. Here we can mark it as 0, 1, 2, 3, 4, etc. Of course, this is number line. So first we can treat this as O, and now A, the value, the point here we can mark it as A. We know that this is unit length, this is also unit length. Okay. Now what we have to do next? We have to draw a perpendicular to this line, to this number line through A, and it should be in unit length. That means here, from this point we can draw a perpendicular to this number line. Well, here we can mark it as B. The condition is this one. AB is perpendicular. Well, it's a perpendicular and it's unit length. Here it's we can have unit length. Now we may join this OB. Now here we got a right angle triangle OAB. Is a right angle triangle OAB. Well, now you see, what about the length of OA? From here to here it's 1 unit, and from here to here it's another 1 unit. Of course, now from OA, from here to here the length is 2. Well, so from here to here the length is 1. So what about the length of OB? Well, we can write by Pythagoras theorem. We can write OB square, hypotenuse square equal to base square plus altitude square. Well, the base here from O to A, that means 2 unit. Well, we can write here OA square plus AB square. Now we can give the values. Well, we know OA is 2 unit. Well, we can write 2 square plus AB 1 unit, 1 square. Now here it is 4 plus 1. So we got a 5. So well, actually what is the value of 5? 5 is the value of OB square. We need the value of OB. Therefore, OB equal to under root 5. OB value is under root 5. Now we know OB is from here to here, the length from here to here. So well, we can mention here OB is root 5. Actually our task is to locate root 5 on number line. Well, what we have to do? So we have to take a compass and keep here and adjust the compass as radius OB and draw an arc. So it should come somewhere here. So here where the arc touch the number line, this point we can mark it as root 5. Why? The reason is very simple. So OB and O we can mark here as D. OB and OD are the radii of the same circle. Therefore, our task, locate root 5 on number line. Well, here it's a position of root 5. Hope you understood. Thank you.